Hello all, this is M. Sandeep Kumar and I welcome you back to my YouTube channel Concepts of IIT Maths. We are in the chapter of Binomial Theorem, and in this particular video we will discuss about the problems where they will ask us to find the integral part of a plus or minus b root c whole power n. They will give a surd like this. They will give a binomial expansion which contains surds, and they will ask us to find the integral part of it. For example, they will ask us to find the integral part of root 2 plus 1 whole power 6. Or else they will ask us to find the integral part of 8 plus 7 root 3 whole power n. And things like this. Okay, not exactly the same thing. They'll give a surd like this and they will ask us what is the integral part. Is it even or is it odd? They'll ask questions like this. Okay, fine. So this is what we are going to discuss in today's video, and at the same time, if the given surd is integer plus fraction, then what is I plus f into 1 minus f? These kind of questions also we will see in today's class. Okay, important model. So let us discuss some examples based on it. If you are new to the channel, do subscribe to my channel, and at the same time I have my presence in other platforms like Instagram, Facebook, Threads and Twitter. So you can search for Math with Sandeep, okay, and you can follow me in the other platforms. I will keep uploading the notes of the videos which I am explaining, and at the same time I'll be uploading problems which might be medium to difficult levels, problems of advanced models. You can find all this, so do follow me in other platforms. Right, let us continue with our video. So here is our first question. So they have given that 9 plus 4 root 5 whole power n is integer plus fraction I plus f, where I is integer and f is fraction. Okay, they have given in the question that the index n and I both are natural numbers, and at the same time f is between 0 and 1. It is a fraction, proper fraction. Then we have to show that the integral part of this particular binomial, the integral part of the surd is what? It is an odd integer. And at the same time we should prove that I plus f into 1 minus f is equal to 1. See, if you understand the first question, all the remaining questions will become easy. Okay, now fine, let us see how to solve this question. I hope you understood the question. First try to understand the question, only then get into the solution. Fine. So they have given that 9 plus 4 root 5 is n power n is equal to I plus f, where f is between 0 and 1, right? And if you take 9 minus 4 root 5, the conjugate of this whole power n, please observe one thing, dear students. Root 5 is approximately 2.4. 2.4 into 4 will be 9.6, right? 9 minus 9.6. Sorry, root 5 is approximately 2.2. 4 into 2.2 is 8.8. 9 minus 8.8 is 0.2 whole power n. So 0.2 is a proper fraction with a positive power, that also will be a fraction, correct or not? So where f is between 0 and 1. In case if you are confused with root 5 values, then do one thing, write this as root 81 and take 4 inside. So you will get root 4 inside the square root, it becomes 4 square. 4 square 16, 16 5s are 80. Root 81 minus root 80 is 0 point something. Okay, now so it is a fraction, right? A fraction which is between 0 and 1. Please remember that capital F is a fraction between 0 and 1. Small f is also a fraction between 0 and 1. This condition is important while solving the question. Okay, next, dear students, in every question we will write two equations like this, and next we will be either adding these two or we will be subtracting these two. We should either add them or subtract them. Now how to decide whether to add them or subtract them is, you should choose it in such a way that in the expansion there are no more irrational terms. That means what? These roots are there now. These roots should get cancelled. Okay, now fine. I hope all of you remember what is x plus a whole power n plus x minus a whole power n expansion. So it is 2 times the sum of the terms in odd place. So in case if you do not recollect this, then check my previous videos of some standard expansions of binomial theorem. Okay, now some standard expansions. Okay, in that I have clearly explained. You have to remember this, that x plus a whole power n plus x minus a whole power n is 2 times sum of the terms in odd place, which means 2 times nc naught into x power n plus nc2 into x power n minus 2 into a power 2 plus nc4 into x power n minus 4 into a power 4 and so on. So this is x plus a whole power n plus x minus a whole power n. Similarly, if minus is there, what happens? If minus is there between them, I will get 2 times. So we will get 2 times sum of the terms in even place, t2 plus t4 plus t6 and so on. 2 times this. So which means, so it is 2 times nc1 x power n minus 1 into a power 1 plus nc2 x power n minus 2 into a power 2, not nc2, I am sorry, it is nc3. nc3 x power n minus 3 a power 3, because t2 is this, t4 is this, and next t6 nc5 x power n minus 5 a power 5 and so on. Okay, now so I will be either choosing x plus a whole power n plus x minus a whole power n, or x plus a whole power n minus x minus a whole power n. Which one to choose means, you choose it in such a way that in the expansion the irrational terms are eliminated. Okay, na? So in this I will choose addition between these two. We will see why. Okay, na? So now LHS, because x plus a whole power n plus x minus a whole power n is 2 times sum of the terms in odd place. That means nc naught 9 power n into 4 root 5 whole power 0. So it is not there. Plus nc2 9 power n minus 2 into 4 root 5 whole power 2. Please observe this carefully. Plus nc4 9 power n minus 4 into 4 root 5 whole power 4 and so on. That is LHS. Observe, after I write the expansion, the irrational terms are getting even power, correct or not? Irrational terms are getting even power, which means that the square root will get cancelled. That is the reason why I chose addition between these two terms. In case here the square root is getting odd power, then instead of choosing addition, I will choose subtraction. That means I will go for x plus a whole power n minus x minus a whole power n. If the square root gets odd power, I will change. Okay, now, but anyhow, when I added these two in the expansion, the square root got even power. Na? This is what we need. And what is RHS? RHS is equal to I plus capital F plus small f. Okay, now next, dear students, please observe. This is an integer because nc naught is a integer and 9 power n is a integer. This is also an integer. The second term is also an integer because root and square gets cancelled. The overall second term is an integer. The third term is also an integer. Like that, every term in the LHS is an integer. Every term in LHS is an integer, and the entire integer is multiplied with 2. So integer plus integer plus integer and so on is an integer. Integer into 2 is even integer, correct or not? So I will write LHS as 2 times. This entire thing is taken as k, some integer k, equal to I plus capital F plus small f. So remember this. Next, dear students, if you remember this equation, because this equation will decide whether I is even integer or odd integer. This equation will decide. We are very close to it. Now let me call this as equation number 1. Please observe that 2k, where k is a integer. Okay, na? So 2k is a integer only, na? Of course it is even integer and it is an integer. LHS is a integer. This is an integer. I is an integer according to the question. I is a natural number, na? It is an integer. Tell me, dear students, integer plus what type of number will be integer? Integer plus what type of number will be an integer? Please think about it. This is our basics. So integer plus what will be an integer? Another integer. So dear students, only integer plus integer will be an integer. Therefore, capital F plus small f must be an integer. Correct or not? Capital F plus small f must be an integer. Now how to know the value of capital F plus small f? Using this. Let us use it. Okay, now how to know capital F plus small f value? So using this expansion. So let me take this. Capital F is between 0 and 1. Small f is between 0 and 1. And I want to know about capital F plus small f. Add the inequalities. So capital F plus small f between 0 plus 0 will be 0. 1 plus 1 will be 2. We can add it directly. So therefore the value of capital F plus small f is between 0 and 2. And at the same time capital F plus small f is an integer. So you can easily say who is the only integer between 0 and 2. This must be an integer, na? Who is the only integer between 0 and 2? 1, correct or not? That means the value of capital F plus small f is equal to how much? 1. Okay, the value of capital F plus small f is 1. So come back to this. Therefore, dear students, 2 times k is equal to I plus capital F plus small f is 1. So from this we can say that I is equal to 2k minus 1. See, I is the integral part of this, correct or not? So now you can say whether I is a odd integer or even integer. Since I is 2k minus 1, where k is some integer, since I is 2k minus 1, it is of the form 2k minus 1, we can say that I is an odd integer. Sometimes they will also ask like this. Step of 9 plus 4 root 5 whole power n. Sorry. Step of 9 plus 4 root 5 whole power n. What is it? Is it an even integer or odd integer? They will ask. So step of this means its integral part only. So step of this means its integral part only, which is odd integer. Sometimes they can ask like this also. Okay, now we will see that in upcoming questions. Okay, fine. The first one is proved. So we have proved that I is a odd integer. Now let us also prove that I plus f into 1 minus f is equal to 1. Fine. Okay, dear students. So now we have this capital F plus small f is equal to 1. We proved it. We have this already in the solution. Now let us see how to prove the second one. Okay, now first of all, take the product of these two. 9 plus 4 root 5 whole power n into 9 minus 4 root 5 whole power n. So 9 plus 4 root 5 whole power n into 9 minus 4 root 5 whole power n. So it is equal to what? The first one is I plus capital F into the second one is small f. So we can multiply 9 plus 4 root 5 and 9 minus 4 root 5 using a plus b into a minus b. It is a square minus b square. And whole power, what is there? Whole power n is there. Do not forget this. Is equal to I plus capital F into, dear students, please observe one thing. I can write small f as what? From here, from small f is equal to 1 minus capital F, correct or not? So I can write small f as 1 minus capital F. So now this is 81 minus 4 square is 16. 16 into root 5 square, 5. So 16 into 5, which is 80. Don't forget whole power n. It is equal to I plus f into 1 minus f. So therefore finally I plus f into 1 minus f is equal to 81 minus 80 will be 1. 1 whole power n will be 1. So we have proved the second one also. See, most of the questions can be easily solved if you understand first question. In this particular model, almost all the remaining models can be solved if you understand the first question, right? Now I'll write a question on the board. You can write yourself. That is second question. So here is the second question on the board. If 8 plus 3 root 7 whole power n is equal to I plus f, where n comma I are natural numbers and f is between 0 and 1, you can prove these two. Same model only, na? First question and second question are same model, just the sets are different. So you can solve them. Okay, fine. You can solve the second question. We will go with third question. Here is our third question. So they told that capital R and small n both are natural numbers. Capital R and small n belongs to capital N. It is epsilon symbol. And capital F is between 0 and 1. So capital F is a proper fraction. And please observe this. This is important. N is odd. the index n is odd number. 5 root 5 plus 11 whole power n is taken as capital R plus capital F. Then we have to prove that capital R is a even integer and capital R plus F into capital F is equal to 4 power n. Same like the previous question. Okay, now fine. Let us get into the solution. So they have given that 5 root 5 plus 11 whole power n is equal to capital R plus capital F, where capital R is a integer, integral part, and F is a fractional part. Okay, fine. F is given between 0 and 1. Next, let me take 5 root 5 minus 11 whole power n. I took 5 root 5 minus 11 because 5 root 5 is larger than 11. If 5 root 5 is smaller than 11, I would have written 11 minus 5 root 5. Please observe. I know that 5 root 5 is larger than 11. How means take 5 inside? It becomes root 125 and 11 is root 121. Root 125 is larger than root 121, na? So larger number minus smaller number always. Remember. Okay, fine. Which is equal to what here? Small f. I'll take it as small f because root 5 is approximately 2.2. 5 into 2.2 is how much? 11.1, right? Yes, 11.0 or 11 point something, because root 5 is 2.24 something like that, na? So it is 11 point something. 5 root 5 is 11 point something minus 11 whole power n. So 11 point something, for example 11.1 minus 1 is 0.1 whole power n, and 0.1 whole power n is a proper fraction, correct or not? So that's why, so when I have taken 5 root 5 minus 11, which is a proper fraction, whole power n, then the answer is also proper fraction. So small f is also between 0 and 1. These two are very important while solving the question. Now dear students, this is the most important step while solving these kind of questions. So you have to decide whether you have to add these two or subtract these two. Okay, you can check it roughly in some rough page. You can check and see what happens if you add these two and what happens if you subtract these two. But what we will choose, which one we will choose? Should I add this or subtract this? Means choose it in such a way that the irrational terms are eliminated. That means square roots must get cancelled. So that is how you have to choose. So I know that we are supposed to subtract these two. If you subtract these two, the roots will get eliminated. Let us see. So if I subtract these two, then what happens? 2 times sum of the terms in even place. T2 plus T4 plus T6 and so on. So T2 means NC1, the first term power n minus 1 into second term power 1. Next. So this is T2. Next T4, NC3, 5 root 5 power n minus 3 into 11 power 3. So second term, fourth term, next sixth term, NC5, 5 root 5 whole power n minus 5 into 11 power 5 and so on. That is your LHS. This is your LHS. And RHS is what? You did subtraction, na? So capital R plus capital F minus small f. Okay. Please observe one thing, dear students. What is the power of these irrational terms? Since n is odd number, n minus 1 will be even number, correct or not? So when the root got an even power, the root will get cancelled automatically. So this root will be gone and this entire term will become an integer. Similarly, n minus 3, odd number, n is odd, odd minus odd will be even. So therefore the power is even and square root got even power, so square root will get cancelled. This term is also integer. Similarly, this term is also integer because the power is a even number, root will get cancelled. Like that, in every term root will get cancelled and every term will become integer. So integer plus integer plus integer and so on will be integer. So inside the bracket we have an integer into 2. So let the integer inside the bracket is k into 2. So 2k equal to capital R plus capital F minus small f. Remember this. Dear students, in case if root does not get cancelled, then you have to change this. So instead of subtracting, you should add. So you have to choose. If you add these two, what happens now? The power of the square root will be odd number, and the root will not get cancelled. That's why instead of adding, I did subtraction. So it is up to you. You should decide whether you have to add them or subtract them, but the irrational terms must be eliminated. That means for square roots the power must be even number. Remember this. Okay now. So anyhow, what is our conclusion in this step? We concluded that 2k, where k is a integer, k belongs to z. Okay now, 2k is equal to capital R plus capital F minus small f. Right now, let us decide what is the value of capital F minus small f using this inequality. Fine. So we have small f between, we have capital F between 0 and 1, and we have small f between 0 and 1. While adding these two, we will add 0 plus 0 and 1 plus 1. But while subtracting, please observe capital F minus small f is between. Capital F minus small f is between. What is the minimum value of this? Means smaller value of capital F minus larger value of small f. So minimum minus maximum. We should take minimum minus maximum to get the least value of capital F minus small f. Correct? So minimum minus maximum means 0 minus 1 minus 1. And what is the maximum value of capital F minus small f means? Take the maximum of capital F minus minimum of small f. So maximum minus minimum. So 1 minus 0, 1. So once again, capital F minus small f is between which two values? Take minimum of capital F minus maximum of small f. So minimum minus maximum, 0 minus 1 minus 1. And what is the maximum value of capital F minus small f? So it is maximum of capital F minus minimum of small f. So 1 minus 0, which is 1. And dear students, please observe this. 2k is a integer, correct or not? R is a integer, correct or not? So then automatically this must be an integer, correct? Only then integer plus integer is integer. So this must be integer. So capital F minus small f must be integer. So the only integer between minus 1 and plus 1, what is it? The only integer between minus 1 and plus 1 is 0. So capital F minus small f is equal to 0. So capital F is equal to small f. Capital F is equal to small f. So come back to this. Therefore, if you want to prove this, what we will do is, let me take, yes, come back to this. Here first this 2k is equal to capital R plus 0. So therefore capital R is equal to 2k, and hence we have proved that capital R is an even integer. Is an even integer. So we proved that capital R is a even integer, correct or not? So using this, now let us see how to prove the second one. Okay, so let me take 5 root 5 plus 11 whole power n, which is capital R plus capital F, R plus F, and at the same time 5 root 5 minus 11 whole power n, which is small f. This is what we have taken at the starting of the solution. Let us see what happens if I multiply these two. So 5 root 5 plus 11 whole power n into 5 root 5 minus 11 whole power n is equal to this one, R plus capital F into small f. Next, dear students, a plus b into a minus b is a square minus b square, and then this has whole power n. So which is equal to capital R plus capital F into, already we have proved that capital F is equal to small f. We proved this just before. So instead of small f, let me write capital F. Now this is going to be 125. This is going to be 125, and this is going to be 121. 125 minus 121 is 4. So 4 power n. So 4 power n is equal to capital R plus capital F into capital F. Therefore, dear students, we have also proved that capital R plus capital F into capital F is equal to 4 power n. So I hope you understood the first model and second model, correct or not? So there are more questions to come in this particular concept. We will discuss the remaining models of the integral part of a binomial expansion in the next video. Okay, in next video we will discuss the remaining models. So thank you, dear students, for having interest in learning all these concepts. Now if you have understood this, do share it with your friends, let them know about our channel, let the channel grow. So, and do comment if there is something to say from your side, and then do follow my Instagram account or Facebook, Threads, Twitter. I have my presence there in other platforms also. Just search for Math with Sandeep, where I'll be uploading the notes, the classwork of the concepts which I am discussing about the problems. I'll be uploading the notes there, so you can get it from there. So search with this username Math with Sandeep. You can find this page in Instagram, Facebook, Twitter, and Threads also. Fine. Thank you. We'll continue in next video.